thank you for coming. Possibly there'll be a few more people who wander in, which is great. I have no intention of going very long here because the Supernova Pit is actually meeting at 11:30. And Rebecca actually said she might come here, and there are enough of us in the Supernova Pit that need to wander upstairs, and we'll probably call it much earlier than that. What I intended today was sort of expand on the little poster blurb that I gave yesterday. And just give sort of a high level overview of the project and kind of some updates on where we're at after a little over 6 months. And actually closer to 9 months now. And look for feedback from you all. If you certainly don't, if you have thoughts in your mind that are cooking after this session, they don't have to be fully baked now, but if you have more solid input that you want to provide, it can always be asynchronously. Just get back to us whenever you want to on things, thoughts, ideas that you have, because you're our customer base, right? You're the community. And we definitely want feedback and input from the Roman community on driving this project. Anyway, so RAPID is the Roman alerts promptly from image differencing. I take full credit for the name and acronym. I do.
Teasing you. Okay. We all agreed. We said that was an excellent title.
Thank you. So, obviously one of the project infrastructure teams, along with the other teams more closely tied to the port community surveys. Monty Coswell is the PI. And Ben Rushholm is our pipeline development lead. At IPAC would be called our task lead, responsible for the budgets and everything else in the task plan. I serve as best I can as the science lead for the project, sort of keeping us all moving in the right direction in that regard. Roberta Palladini is sort of overseeing the galactic transients end of things. She's not here now. Lynn Yan is the testing and validation lead. Lynn's over here.
I don't know why I'm doing simulations though.
That's part of the testing and validation. And Ashish Mahabal, who a number of you know, is looking to develop source classification, sort of expanding the source classification by machine learning from ZTF over to RAPID. We have Joe Masiero, who some of you may know has been very intimately tied with NeoWise, now Neo Surveyor, solar system object expert, and obviously there are going to be lots of solar system objects that are going to wind up in Roman images in the time domain survey, etc. So we look to recover those as well and provide tracklets if we can. Russ Lahr is here. He's our senior development lead. And Jacob Jensen is doing just about everything on this project. So we're very appreciative that he's part of the project here. Okay, so I really don't need to show you all this slide because you obviously understand what the motivation is for this. But clearly there's a lot of discovery space for transients in the infrared that have been started in the past with various surveys, including with Spitzer. The discovery even of new sorts of transients, obscured transients, both in the galaxy and extragalactically. Things at high redshift that should be intrinsically red just by virtue of that are observationally red. So all kinds of space that can be filled in on this luminosity timescale diagram. And the plot over to the right is kind of a complicated thing, but basically the upshot is that Roman should be a very efficient machine for time domain discovery and analysis. just based on its overall, even though the amount of sky it's covering is fairly small, just based on this volumetric survey speed metric. So as you all know, the core community surveys are accounting for about 75% of the 5-year prime mission, with the general astrophysics surveys, the guest observer program occupying the 25%. You know, we sort of understand what the 2 time domain surveys are doing in terms of discovery. The wide area survey is still a wild card in that regard, how much transient, how much time domain can actually be done with that large area survey, still to be established. And of course, the general astrophysical program is wide open, so we have no idea what people are going to propose in terms of both non-time domain that can be exploited for time domain and pointed time domain sort of programs. So our goal with RAPID is to provide 4 services to the community. Rapid image differencing of every new Roman image. So every observing campaign that gets processed by the Science Operations Center at SDSCI will be something we will analyze with a reference image. And after that image differencing, there'll be prompt public alert stream to, you know, to all of you of anything new, both variable and transient that and solar system that we find. Source match light curve files for every Roman identified candidate, and a force photometry service for the photometric history. So all of this is sort of ZTF based. These are things that many of you are already familiar with that are interacting with ZTF. Yeah, Rob.
For the force photometry service, is that force photometry on difference images or force photometry on the original or both?
I believe what we're going to try to do, and unfortunately Ben's not here yet, but it's on the difference.
Okay.
Yeah.
Because, you know, for things like variable stars,
Right.
the original, although if you're near the galaxy, deflatted, whatever. Yeah. I mean, as a supernova guy, of course, what you said is what I want.
Yeah. So that, you know, there's a little more latency on the force photometry versus the alerts, but it's all part of the main stream here.
And tell me to go away if you're going to tell us this soon. How hardcore do you plan to go with calibration and stuff like that? Is this entirely a discovery pipeline where it'll be good to 1% or 2%?
Or the photometry will be what most would consider quick and dirty. Don't do cosmology with our alerts. So,
Yeah.
Do our own.
Yeah.
I think the whole goal is the time. We
Yeah.
want to be as there's no latency. It should be
Rapid.
rapid.
Yeah.
So that's the goal,
Okay.
not accuracy, not.
Correct.
Thought about how you define reference images, right? It's not like CTF where you survey the sky and say, okay, these are our references and we come back. There's gonna be a broad range of programs, like.
Yeah.
how's
So
that gonna work?
I have a slide a little further down, but I can give a quick answer to that. So the plan that we propose is to take, you have an image, that image automatically becomes a reference for some future image. And so let's say it's a 30-second exposure in one of the bands. Then later on, there's another 30-second exposure in that same band that overlaps by, and the N is still TBD. You do a subtraction of that single frame from the new science frame. If then there is a deeper 100-second frame in that same band, then that becomes the new reference for future frames and so on. That's the level 1 plan. We're still toying with the idea of building reference mosaics, if we get that option. Much like the other pits want to do in terms of both galactic bulge and the time domain survey. But the going in position is we use single level 2 images and match them up spatially and do subtraction.
If I understand correctly, you won't provide image subtractions if the only previously existing image has a shorter exposure time?
If,
So if there's,
yeah, if there's a longer exposure downstream, then the shorter exposure that we've had as the reference will get superseded by that longer exposure. Will we do a subtraction of the shorter one from the longer? Probably not.
yeah, okay,
Yes.
Sorry,
you could,
you said different things.
really?
You asked if the template is shorter, will you
Yes.
not do the subtraction?
And it sounds like that's true.
Yeah, I think that would be our
But
going.
I don't, sorry, image 1 was 5 seconds,
Yeah.
image 2 was 100 seconds,
Sure.
image 3 was 20 seconds. So image 1 was taken, it's 5 seconds, image 2 happens, it overlaps. Yes, that subtraction is done.
2 minus 1.
Oh, it
2
is.
minus 1 is
Uh,
done. That's the question.
2 - 1. If you have a short reference, if the science frame is longer than
Yes,
the
Yeah, that's the
reference,
question.
I believe our plan is not to subtract.
But isn't it arbitrary? I guess
Well,
that's the spirit of the question.
We don't know the reference algorithm yet, on, you know, when we generate it, so probably we would, so for that case, we would probably. And my belief is we should probably subtract wherever is possible, just because we consider that latency. You know, so it gets things out for follow-up, but then when the criteria on which we regenerate the reference. Is
Sure.
undecided yet, and I was thinking it was going to be fairly dynamic, but we talked with a lot of the downstream
Hard
brokers.
to track, right?
For our external advisory board, and they were like, no, we like fixed references.
Yeah, it makes,
You know-
well, it makes rates much easier if
Yeah.
you fix references.
Yeah,
Didn't it say,
So-
otherwise, whichever. Oh,
so, so some of this as well is I would like to know just like AWS dollars, how expensive these operations are. Because, you know, I think I would like to reprocess, I would like to improve the reference. You know, on a fairly fixed cadence, I think. And but I want to know whether that's kind of feasible or not.
But back to Sebastian's question, it's symmetric, particularly in space, right? It's not like there is a better seeing template or something. like
No.
that might be from the ground,
Right.
but- So in space, it could be much more symmetric. It's not particularly obvious that the order should matter.
Yeah. I mean, the roll angle and coverage is going to be.
Oh, what to do about a PSF at different roll angles and spatial thing? Yeah.
Yes.
Well, it's even crazier than that, right? Because the reference could be SCA3, whereas the science frame is
Absolutely.
SCA10,
Right,
right?
yeah.
What is this? What is SCA?
Detector.
The-
Oh, sorry.
so it's mostly a matter of just scientific goal, which one you subtract from which one. If you get an alert of, oh yes, there was a bright source 2 years ago, oh, cool.
Sorry, no, but there's symmetric.
Sure, not for the operations, but for like scientific goal, like if you detect a transient in the new image, you can do something about it. If you detect a transient in the original image from 2 years ago,
So, but you're,
like if
I don't
it,
mean to get your argument. When you say transient, you mean positive.
yes,
So that's, but if you don't,
I
then
do.
it's symmetric. That's all I'm
Fair
trying to say.
fair, yeah.
But okay, sure.
Put it in humor.
Easy to multiply.
This is great that we're getting stuck on slide 2 with a lot of really interesting.
But I
discussion and valuable
I was curious on the who's paying for the 3 extra copies of all images ever taken, which I think you were asking about.
I mean, we would keep record. So I mean, another potential thing is that the SOC are going to make mosaics. On that, I think it's annual timescale,
Right,
might be
right,
6
right, right.
months. 6 months. 6 months. So, you know, perhaps we just use those for the references because then it's kind of consistent and
Yeah,
understood. So, you know, I think we would make our. You know, perhaps we have our own interim references, you know, perhaps.
Like
after-
year 3 is different than like month 1, so.
Yeah.
Yeah.
Right.
And, you know, as I see it, we don't have to be necessarily the canonical exquisite photometry. You know, our job is to get stuff out
Right.
quickly for follow-up.
And do you have requirements on people's abilities to recreate selection and rates and efficiency?
There's no requirement on that.
Yeah.
no.
That will make your life easier.
Yeah.
Yeah.
I mean,
I'm not saying there should be.
do you have plans on estimating your efficiency and selection?
Yes.
Stuff like that?
Yeah.
So that's a part of the, you know, we are doing the simulations, which
Yeah.
will do a grid of, you know, you drop simulated sources as a function of magnitude, the environment, and then you can recover it. So this is the part of the test on the pipeline, that how these various image subtraction will work
And is
as
this,
a function.
is this simulations before the whole thing goes or
We're,
alongside during?
we're using the same open universe, to start.
I think we'll end up doing source injection.
Yeah, we
During
just
it,
do
so it's
this,
pretty-
just do simple source injection.
Yeah.
So this is all in the plan, but I'm saying to answer your question, whether we
Yeah.
will quantify our algorithm, it will be done, although it's not part of the requirements that, we're just doing this to satisfy our own.
And this is great, the pits have no requirements, so.
Yeah.
You know, but in terms of,
Store
kind of needs some
requirements.
requirements to make prioritization decisions about.
Yeah.
research.
Yeah,
So,
just to answer that, it's
thank you.
planned.
Well, hang on, Ben, I
Yeah.
think Seppo has.
So it's the plan to make the difference imaging pipeline available, so that anyone can run it, and will there be any problems if you want to select your own reference, play with the roll angle of the PSA? and
Yeah, I
things
mean,
like that.
it's all,
Yeah.
all
Well-
of this is supposed to be public.
Yeah.
Well, it is public. So, I mean, all the code and, our templates and our infrastructure's code will be available. We will not be providing resources to run it. So, it's some, I don't know how easy it will be to replicate because, I don't know yet how we're doing the like IAM roles and secrets management. So what's your onboarding? I don't know. But yeah, nothing's proprietary.
Yeah, like any pair of images you can totally do, but if you want to in parallel run a whole suite of stuff, then you might have orchestration workflow tied to a particular cloud implementation.
Even a pair of images can be complicated depending on how the scaffolding is.
Yeah. So that's what I'm saying. We're not providing a service where you can run any of it.
Yeah, so I'm wondering, I mean, if the expectation is that by optimizing the image subtractions, you might be able to do better if you do it offline, kind of more careful work,
Right.
select your references or the pipeline
I
would do like
would say-
almost as good as
Yeah, of course,
possible.
that's the opposite of rapid, so.
Yeah, exactly, I know, yeah, so, yeah, true, but yeah,
I fully
kind of
expect,
spin off, yeah.
I fully expect that. And as I say, I just want to warn, I mean,
More like a rare.
yeah, our priority is latency. We're going to do as good a job we can, but nothing's going to be bespoke. It's going to be automated, best case, hands off, occasionally redone. If you want to, and our thresholds will probably be quite high, especially in cases, as you say, where there haven't been observations for a long period of time. If say there's a geo thing on some patch and then we come back a year later, we're not gonna alert on every single variable star, but if there's some whopping great big thing there, the threshold will be high, like that wasn't there last time. Go check that out. So, yeah, there's going to be a lot of room for, if you care in detail about things, to really make precision. There'll be a lot of space, we're just a precursor to help you discover things that are interesting in the model.
I will say, I will add to that. So you're interested in doing something simple like, relatively simple, like subtracting just one pair of images, right? There's a Roman science platform that's on AWS, and you can do that, and the SOC will provide the computing power to do that, as long as it's small, right? But if you're actually planning on reprocessing a huge amount of data, then you submit a proposal to the SOC, and then State Scope will give you some allotment to you and your group to run all those things, and all of the presumably rapid code will also be on the Roman science platform. You don't need to download it, and you're actually not recommended. You probably shouldn't download it.
Yeah, I mean,
And you can run everything there.
we haven't seen the science platform yet, but obviously if there's anything there, we can make life easier for everyone.
It exists as a platform physics, so.
Right.
But that's a good point. I was just writing down, both the supernova bit and rapid tension, where it's possible, does it run on the Roman science platform? If it doesn't, there's some good reason, otherwise, yeah, make sure that.
Sorry, Ben.
No, this is fine, because I was gonna go back a little bit. You mentioned the mosaics might be a good template. But I'm not sure if the SOC is doing mosaics outside of the core community surveys. All the GA,
Yeah, that's,
Right.
that's true, I don't think they ever find it.
so
I think not even the Galactic Plane Survey,
that's interesting.
Yeah.
That really.
yeah,
probably should
because
be.
there's not enough budget for the Galactic Plane Survey.
It's a late edition, so
Yeah.
they're not gonna do it. The full one's been planned for a while.
Yes.
It's an early GAS, basically.
Well, there should be budget somewhere for that, because that survey without a mosaic is kind of pointless.
But yeah, we have to decide that this is for the next 4 years. I think that's our main goal, and we just have to be clear and consistent about what we're doing. I mean, my preference would be to use official things where
Oh, I think
possible,
that's a good idea, but,
but, you know, you gotta figure out with the timescales and.
and once you start pulling in GA, it's just so, inhomogeneous that you're gonna. That'll be
Yeah.
fun to deal with.
Yeah, so there, you know, as I say, the thresholds will be very high. Whereas, you know, the highlight and time domain survey, we can go deeper.
It's a little more uniform.
What's slide 3?
Brad, did your question get answered?
Yeah.
So you stimulated a lot of it.
I caused trouble, that might.
All right, but you know, I don't need to tell you that obviously it's important for us to get busy with this as soon as we can. So, you know, we've obviously been working as hard as we can in this 9 months to begin setting up our infrastructure and developing pipeline modules. And then, of course, we need to string those pipeline modules together. We're trying to get feedback from you all and from our alert streams that will be taking our products. But all this needs to be obviously in place before the observing begins. And, you know, you heard Julie saying October 26th looks real good still. So that's 2 years and some change from now. So it is a challenge to get this all put together. So, you know, again, the technical plan, our low latency is our goal, is our driving factor. The
Hey,
data-
Skylar, sorry to interrupt. I don't think you're sharing your slides on Zoom.
Oh,
Sorry, here.
Wow.
All right.
All that
You
time.
didn't
We
miss a
didn't
lot.
know.
Yeah, we have to go back.
I imagined everything you were showing.
all right, so let me, trying to do all the technical things here. Okay, here we go.
No, I don't mind.
All right, how about now?
Yep, that looks good.
So I can back up 1, 2, all right, there you go, our tools. So you heard a lot of
We can't
discussion.
go back at the end.
Yeah.
Just continue.
All right, now to get back to my slideshow where it went.
This is fine.
All right. Okay, so the data will be available to us, the level 2 data within 48 hours. How we're still working those details. Everything we're doing is in the cloud. It's Caltech AWS. The level 2 data are supposed to be in the cloud as well. So it's just really a question of getting from one S3 bucket to another. Presumably that can be done within that 48-hour window. That's not hugely fast for people who are interested in really fast transients, unless they're, you know, sufficiently high redshift. But you know, we're limited by the downlink in the processing. But within an hour after that, we'll have the image differencing done and a prompt alert out with an initial classification based on machine learning algorithm. The force photometry and the appended light curve will then follow within about a day's time scale, and all of our products will inevitably find their way to PAST over public distribution.
What's the unit here? Is the unit image? Is the unit a 10 hours of images? Exposure. It's exposure. So, and how many exposures?
Well, it depends on
Per day?
depends on what's happening. I mean, it's just.
Yeah,
Thousands?
Yeah, it's so that 48-hour turnaround is, you know, the end of their requirements, which weren't done. Yeah, it's a lot quicker. It depends on how they're downlinked. I mean, you should have fairly good downlink coverage. This was my main worry when writing the proposal, that we were going to get like 1 downlink a day.
Yeah.
But from what I understand, talking to people,
The 3, okay.
yeah, there's 3 and it should have very good coverage. So, you know, just my assumption is for once a exposure is made available to us, we would turn it around in under an hour. Which is fairly generous. I mean, you know, my worry is obviously a very there's a very long tail when you get to crowded fields.
Well, there's that. I guess my question is, if you get 1,000 images.
Yeah.
And you got them all at once, so you said you're gonna get back in an hour, that's 3.6 seconds on a single core,
Right.
which is not what you're doing. So that's why I was curious about how does per image per hour scale, because like that's not serial as parallel.
So as opposed to CTF, we had, Rust started playing with AWS batch. So it's just, we can just dump. I'm not so worried about the parallelism there, about conceiving things in bunches, because we can just scale up and down pretty well.
And we'll have a sense of that bunch because our goal, our intent hopefully is to get the observing schedule for a block ahead of time, so we know what's coming.
Yeah, you're gonna preload.
We'd have things primed.
Again, this is something we'll find out in, as we develop it, because the ZTF, we do pre-place some selected catalogs and queries. But yeah, just for speed, but again, I don't know whether it's worthwhile, it's the kind of thing to test.
So your answer to this hour is, the hour is a pretty loose, easy thing to meet. Because you think you can burst to 1,000.
My worry is more the number of sources in the field. Because a crowded field takes a lot longer to process and do a lot more queries of
After level, and the subtraction itself.
Yes. For ZTF, like crowded fields with a lot of alerts.
Yeah.
So for ZTF, what we really should be talking about is, percentiles. Like
right.
ZTF P50 is 11 minutes from should have closed it down.
Uh-huh.
But P90 is 20 minutes, and then there's a very stubborn long tail. So hopefully we turn around most things fairly quickly, but yes, to tell that.
And the endpoint is the alert screen. Yeah, so you are assuming the existence of the same brokers that are kind of around now.
Yeah,
Just
and obviously the goal is to engage them throughout this whole process. As you'll see on our executive advisory board, we have a smaller thing. So, but we certainly want to talk to Alerce.
Well, they talk to all the usual suspects, they know we exist.
Yeah, Ben was at the Cosmic Streams meeting down in Chile. All right. Let me ask the people online, are you able to hear all of the discussion that's going on in the room? Pretty much. Okay, thank you. All right, so here's just our cartoon block diagram of how this pipeline is going to work with tweaks TBD. But it's really just leveraging everything that was built for ZTF. A lot of the similar ideas behind it. Okay, and so this was the slide on the references. And this is basically taken from what we proposed. And we're going to iterate with this as we know more about how things are going to happen. But again, we're in a situation where things are not all on the same grid. They're not all the same orientation, or not the same exposures necessarily. So it's really kind of outside of the main surveys, it's kind of a hodgepodge of things downstream. And so, it's something we have to be flexible. I think we constructed sort of an idea of what would define the overlap, but that just is going to be certainly iterated at this point. A lot of it's going to be based on how Roman winds up gridding the sky, etc. But again, nominally the first exposure of any given cell in the grid becomes the reference image. And then as I said earlier, it's superseded by whatever's the deeper level 2. This again, just at the level 2 frame that comes later. Okay, again, as we said, we may either build reference mosaics ourselves or rely on the ones that are pre-built. Okay, so, our goal, what we're spending a lot of time on at the moment is optimizing our image differencing. The algorithms that are, the best algorithm to use. We know Lauren is spending, a lot of energy at this point in time for the supernova pit and trying different, algorithms. And so, we're trying to have some, collaboration on that. And so this is a lot of what's occupying Jacob's time at this point is going through the various algorithms that we've sort of zeroed in on and testing them. It's not just a question of the metrics of, how good the differencing is, but, we have to take into considerations, volume and processing time and CPUs that are necessary, et cetera. So there's the computing infrastructure that needs to be taken into account for what we're trying to do. Okay, and then as I mentioned, we're trying to follow the ZTF mode in terms of source classification based on machine learning. Ashish has been, using these convolutional neural networks for various different types of variables and transients. But obviously work needs to be done to optimize the sort of classification scheme for Roman. We could we'll try to do some of that from the simulated images. But a lot of the classification training can be done on the catalog level as well. At least as I see it. People have feedback on that. Please feel free to let us know. So pre-launch development and testing are underway. We've been using the existing simulated Roman data. Troxel talked about the NASA Open Universe simulations, which have been very graciously made available to us. So we're trying to exploit those as much as we can now. We also have the folks developing the microlensing pipeline just around the corner from us in the same hallway. So we've been able to get at this point, a sample of the galactic bulge sims with, a larger suite of simulations to be offered to us. So that's all good, because, that's great that we don't have to build a huge mountain of simulations to do our testing. But the open universe sims only have so many transients in them. And we'd like to be able to complement that with additional transients and variables. And the same is true for the galactic bulge sims. They're primarily obviously concentrating on microlensing events, simulated events. I know the microlensing team, the RGIS pit, for instance, wants to inject other galactic variables and transients into their simulations, and we'd love that. We're more than willing to help them on that, because there are going to be all kinds of other things in those fields that don't necessarily interest the microlensing folks, but will interest, all of you. And so we need to inject those in, and also solar system objects. None of the simulations have any solar system objects in them. So we're actually going to use real solar system objects, real mappings that have already been developed for Neo Surveyor, and inject those into the actual fields, at the right RA index and epoch.
How potatoes or?
All kinds, asteroids, all kinds of things.
Out the hundreds of AUs?
Joe's not here, so he can give you the details on that mapping, but it's a lot of the same objects that, surveyors going to see on a daily basis.
What's your plan when you have a solar system object and linking and all that sort of stuff? Are you learning on that?
I think I have a slide on that. And Joe's, I don't think he's online either, to comment. We haven't worked that plan completely. But Joe has thoughts in mind on how we're going to do that and what we're going to release.
And before that, are you going to do occupations?
Now you're going down levels of exotic, I heard.
How about Abbey Loeb spacecraft?
My understanding, from talking to Joe is, rodent's not really a SSA discovery. I think it's very good for getting effectiveness really well. So I think that's really what he's focusing on.
Yeah, and there's complementarity both with Ruben and with Surveyor from the different perspectives, different places in the sky. So, Ben,
Yeah, so I can't remember where I heard this from, exactly which telescope it was, but it seems like L2 is getting crowded enough that the telescopes are discovering each other.
I've always
So
done
we
it.
like discovered.
Yeah, if I remember correctly, one of the telescopes was discovering GWST a lot.
Can we look at each other?
So I don't know what your plan is for that, but that might be something to,
I mean, there's a lot of stuff we have to mask.
yeah.
I mean, did you ever see that? I mean, they've got the grace of God go Did you ever see the astronomical telegram by the person who previously got Mars?
Yeah.
Yeah.
Mercury?
Mars.
Mars.
Yeah.
It goes an award on Twitter and everything.
Mars is like, right?
So did it say we newly discovered
yeah,
Mars?
Look at the size of that thing.
Well, the cool thing as well is the resonance real too. So like on Planck, Planck with the orbit and the way it was pointing, you saw Mars twice and they were very close together because they haven't, everything matched up. So we've seen on the same mountain planets.
right.
Have you thought at all or talked to anyone at all for your pre-launch development about getting a hold of the prime data?
We haven't.
I
That's
think it's
interesting
worth
suggestion.
thinking about. It's the same detectors that are on Roman.
Right.
Doing the microlensing survey of the bulge 50% of the time. They have a ton of data already. Seems like it would be a good, on sky, on the ground, a good test case.
Yeah. That's a good suggestion. Yeah. So-
How deep is the prime data, do you think?
I don't know. It's on a 1.8 meter telescope.
Ah, okay.
That's like 2.4.
Yeah, I think,
Will definitely help with the,
Takahiro briefly talked about it yesterday.
The seeing is not that good at sight, though.
It's not good.
oh,
I guess the Earth.
Well, we'll still look into it. It's a good suggestion. Just before we leave this slide, one of the things that our executive, and this is Ashish for anyone who doesn't know Ashish. One of the suggestions from our executive advisory board was to go and look, use available data, and we actually had put this in the proposal that, there are great to have simulations, but there are real data on sky from HSD and from JWST that can be exploited for this sort of testing. And I, very early on did some very, very boneheaded image differencing with C3IR, from Syrah and raising the supernova programs, and it can be done. But if you do, sort of the FLT versus FLT, different orientations and stuff, you have all the distortion. So you have to take all of the distortion out before you do the image differencing. So that's something we realized you either have to blot the reference to match the distorted frame, or we have to bring both frames up to the same undistorted grid and then do the image differencing. These are things that we have to consider. Okay, and then the alert stream that we produce and disseminate will again follow the ZTF model to start, but obviously we will iterate that with all of you in the community. But we'll provide position, an initial flux measurement, rolling, excuse me, a rolling light curve. Again, this is just going in. If you all have better ideas of how this alert stream should look, please let us know. Our goal this quarter is to prototype an alert packet for comment, criticism.
So
When you,
Yeah.
when you say image there, that's all the chips, or is that one chip?
Oh, no, that's just, there's a small postage stack cut out from that exposure. So that per
I'm
exposure.
talking about the 1,000 alerts per image. That's for all the chips together, not for one chip, is it?
No, that's, that comes ETF, it's 1,000 alerts per quadrant ETF.
Those numbers are not for Roman.
That's a lot. Okay,
Yeah, well, and, you know, it really depends on your threshold. I mean, this is something that I would like to know, you know, so with ZTF, when we set it up, you know, we cut quite high because, you know, this alerting was new and we didn't want to have a flood downstream that people had to wade through. So we set it, you know, to 5 sigma, and Ruben has set it to 5 sigma because that's what people are used to. But if you go to conferences, a lot of people, especially the AGN, are like, can we get it 2 sigma? So again, this is a trade-off. I don't know where it is, but you know, what alert rate do you want and what threshold do you want? And that would be good to have feedback on that.
It's not hard, like I said. So there's a Gaussian random field tail against the source signal, like, it's a pretty reasonable choice.
Yeah, and well, I mean, it just goes up. I don't know exactly, you know, what that function is.
Like at 1 sigma, we could just evolve the PSF and set that up. Yeah. No, sorry, the spirit was, part of this is educating the expected users about what is possible, what's reasonable, what sort of makes sense.
But, you know, we do want to hear back if people have, you know, we prefer something different. I mean, you know, this is from, I mean, hopefully the image quality here is a lot more expensive than CTF. So, you know, perhaps we can be a lot more accurate.
But that doesn't change the signal noise threshold, right?
Well, but there's a lot of boguses. You know, if there's a signal to noise threshold, there was a real bogus cut. You know, it was just, I mean, it was literally, you know, we had to ship and we made this decision.
Sure, no, I think you made good decisions. I didn't even criticize that. I meant for Roman, I don't think it's reasonable to say that you should have to take down below 5 sigma. Like these detectors are large, like a Gaussian random field generating.
Yeah.
Substantial numbers of detections, even if you're working perfectly, if you start going down your signal.
I think 2 numbers that may be worth considering is also how much can be consumed, but also how much people are actually going to use. So I've been doing some analysis with ZTF data, and of the number of alerts that are produced, there are many science groups who have their own filters, whittling down things to see what is of their interest, and then of that humans look at some and do follow-up of some. So if you look at combine all the science group, it ends up being far less than 1% of alerts where anything gets done.
Right.
But then for statistical studies, using a lot of these can be useful. So again, it will depend a lot on how much data can be handled, what is it that we should put out there rather than not put out, and what to do with that. As Ben said, there are many boguses in there.
Yeah.
To start with. But even understanding how to separate boguses will be a good thing. So I completely understand that we should not be doing very, very low things. But initially, we may internally want to look at many of those still.
I think, okay, that makes.
Of course, I'm not super familiar with ZTF, but I know there were like seasons with that for Roman. If you have, say, a long duration transient that crosses, say, multiple bulge seasons, will that be connected to one single light curve, or how will that work?
Light curves are different
Yeah.
to alert. So
Okay.
alert usually only has, again, this is a trade space of like how many alerts how big do you want your database query to be? So ZTF is limited to a 30-day history. It's something I want to again check for in the alerts, because you have to do it real time. The light curves, you know, are generated, you know, you have more time to generate those. So those would be the entire observation history.
I see, so
Will
be,
be matched,
okay,
source will be matched. So you will not lose your old data.
I see.
Otherwise,
Okay, yeah.
it will be disastrous. If you rediscover your old object over and over again, that's
see.
wasting time.
Okay,
But like, for example, in that example, if you're using, say, the force photometry and you have a really long transient and the reference image gets updated halfway through the transient, it's gonna be discontinued.
So this is the one question that we didn't get discussed.
Need to go back and reprocess.
Yeah, that's the
Which is fine.
reprocessing.
So, as long as I'm aware that that's what's happening, yes.
Yeah, reprocessing topic is, as Ben was saying, it's undecided yet as to how frequently we want to.
Yeah, so
reprocess.
this is why I gave a spiel at the last community meeting about the importance of simulations, is because there's a lot of knobs here to turn, to tune. And I don't necessarily know for this kind of data and this processing platform, you know, where the optimum is. But, you know, I really want to hear from people is, you know, if they have things that are really important to them, you know, please let us know so we can tune for that.
So it's not quite precise, but it is accurate to at least save the diff between the templates, right?
So,
If someone wanted to crude like to a few percent once they offset, you have to provide that from the diff between the templates. To make sure that like that's one of the things you're gonna be forced to talk through. Just as a rough like.
But with a deeper reference image, you can imagine if your reprocessing will rediscover, well, not rediscover, will discover new transits, right?
Yeah.
Because you're using a deeper reference frame. If you reprocess the old data, you're gonna see much deeper. But the problem is, what I'm saying is that we haven't decided, this is sort of, there are many factors determine this. You might not want to reprocess very frequently because the goal here is to rapidly discover new transits.
Right.
The transient just exploded. If you do too much reprocessing, you're stuck with the old one, and you know, there's a trade-off there.
I thought reprocessing was out of scope.
For us, it probably is at this point, so.
I think, you know, there's going to be less data than ZTF, so, you know, perhaps we will have, you know, it's on the table is we would have releases where, you know, perhaps we'll change a lot of things and redo it. But again, I don't know if that's practical or that's desirable.
I think if you're just doing like going to the point of the first two rapid alerts, that's not.
No, but people are going to use it, and my big worry for rapid thing that, you know, there's only going to be 70 Roman images. Force photometry, there's an insatiable demand, as we're finding with ZTF, and you know, so there's no bound to it. I mean, like as we improve the ZTF force photometry service, it gets saturated, you know, and then we increase it to 3 per. Again,
Is that wrong?
it's not me.
No, okay.
So, you know, we want to make sure that's consistent and usable by everyone, because that's a product. And, you know, again, it's got to be very well documented. You know, because people are going to use it for what use that it wasn't intended, so we've got to make sure that that's the product. But, you know, wrong. But where the boundary between us and the SOC is, I don't.
Yeah, so I was curious. Sorry, you're making me nostalgic for when I got blocked by the NPC, but, yeah, what's the integration with the catalog of the sky? Like.
Sorry.
Along that lines, the objective then to produce for every transit or object that may go off a hosted stat series and that like that will change multiple versions depending on the average and some of the.
I think we're going to want to tune and change at least once. And so we would have some kind of, you know, block A, block B, and there would be overlap, obviously. So you know, as we learn on the sky, you know, what works well, you know, I'm sure we're going to want to tweak something. So I think.
So you use the posted stats and I like those.
No, well, the alerts are fixed in time. Don't go back and reissue alerts.
No, I mean,
But for
what
like-
you provide as a product to the community posted stamps of the area around your object of interest. Or would that be, and then the light curves that follow that, or would the, and because you're going to adapt, so you're going to have the difference in, so you're going to have your objective difference imaging, and then your light curve that will produce from that. And so those things will you reiterate, and how are you going to?
yeah, we'd have to be, so postage stamps we wouldn't. Because we just generate those on the fly. But yeah, we would have to go back and redo the difference images and all the products from those. But as I say, I think it would be done in parallel and probably would provide both. For some time to allow people to switch over. I mean, we've done this for ZTF, but not done reprocessing, but we've done additions to the product. And it's very important to keep things consistent, especially because people will train machine learning algorithms on them, you know, and so, you know, they want to keep those filters going. So probably, I mean, it may actually even have to be additive, like we'll have to just do two streams rather than stop. But, you know, for the length of the normal mission, I think, and the length of the extended mission, I think people are going to want improvements.
And then you're gonna, like you said, you'll not keep the business stamps, you'll.
No, so the postage stamps, again, this is saying, you know, what we did for TTF is we put postage stamps in the alerts. So everything was there. So that actually is a large part of the alert volume. And again, most people are not looking at all the alerts. And so is it better? There have been suggestions of putting all the postage stamps just in a bucket somewhere, you know, so you can look up the ones for the alerts that you want.
So there's a reason why I'm asking these questions,
Yeah.
because I'm trying to figure out how people might interface in that way and go back to the thousands.
Yeah. You know, for a lot of this alert schema stuff, I'm also looking a lot at Rubin, because for the brokers point of view, you want to keep things as consistent as possible. So the Rubin is very much based on ZTF, but they're going to iterate some things, and probably we will adopt as much of that as possible. But I mean, it's a weakness of ZTF is that this alerting was added very late on, and it was purposely limited in scope. So we don't have a good alert archive or alert tools, and you know, I would like to improve those for Rapids, if only for my insanity, because I get emails to say, what's up with this alert? They give me a 12-digit number, and I'm like, I don't know.
Okay, any other question? Oh,
Sorry if you
yeah.
mentioned
Sorry.
this before I stepped in. Are you doing this for the wide area survey as well?
Well, I mean, it'll, if they do enough redundancy of coverage with, you know, enough of a time, time gap greater than 0, right?
Yeah.
Then yes, but I mean, I think it'll depend on what the committee decides on the strategy for their survey, whether they integrate. I mean, I know there was at least one white paper that was advocating for at least one additional epoch, if not more, for the wide area survey to facilitate finding. But
Because I suspect, you know, many of the interesting candidates for the majority of the people is probably going to come by.
Yeah.
The supernova.
We will alert where there's repeated observations,
Yeah.
but the threshold will be in there.
Yeah. But most of the high latitude time domain survey sources are going to be 24th. No, right, 24th magnitude, not many people are going to be able to follow it up.
For sure. Okay, it's my intention, and this is also for the people online, that to try to wrap up in like 25 minutes or so, because to make time for the supernova pit, which has a lot of overlap with many of the people in this room. So, you know, I'll try to get done by 20 after. So we'll get as far as we do. All this discussion has been fantastic. We really appreciate it. And I've actually been have the Zoom on record, so we can capture it. So sorry, I didn't warn you ahead of time.
Make that forward waiting for you.
Yeah, it did. Okay, we won't beat on this too much more, but you know, the idea is to again follow ZTF model in terms of force photometry and light curves. There's been a lot of discussion already about the force photometry here, unless anybody has some further questions on this. Okay, these are our anticipated data products and deliverables, which could change. For one thing, we thought we were going to make lots of simulated images. That was part of the proposal. It's TBD whether we, keep the ones that we enhance with further transients and have those as a deliverable to the community. For instance, taking the open universe sims and what we add to them, making those available as well. But originally we thought we were going to have to build a bunch. We just hedged that we might have to build simulated sims for ourselves, and simulated images for ourselves. Reference images, the difference images, the alert stream, the alert archive, and the light curves will all be deliverables, all of which, well, most of which will wind up in mass inevitably. If you can think of data products and deliverables that you think we should try to provide that are beyond this slide, let us know. Yeah, Sebastian.
The expected data volume rate for Roman is like over 1,000 terabytes a day. Is the number mostly because most of them just don't have an overlap? Is that why it's only 100?
Yeah, I was, as you say, I was looking at this, I'm like, because I know I generated this for
Yeah.
the proposal, and I'm like, is that right? Yeah.
Seems quite low.
It seems low. I mean, so, all those things are, all the intermediate products.
Yeah.
So this was scaled off the raw number, but yeah, those are to be.
Okay.
Okay, so we're optimizing, currently working to try to optimize the image differencing so we can down select which algorithm we use at least in the prototype pipeline. And so Jacob has been looking at both Zogi and this SFFT fast Fourier transform algorithm that's been developed. I could spend a little bit of time on it. Maybe Jacob, if you wanted to talk a little bit to this, but it was basically the trade study between the computing that's necessary and all the inputs that are necessary, whether the algorithms require PSFs to start, et cetera, that's been going into our analysis. Let me see if I can. Yeah, and then Jacob's been looking at the hybrid of cross convolution, similar to Zogi plus SFFT, and making this same sort of checklist. This looks a lot like your checklist, Lauren. So we may have actually stolen this checklist format from you, but it's a lot of the analysis very similar that we're doing it.
So I would like to say for anyone working on image differencing, I would like to know the production cost, because I see people like, oh, it's one image difference on a A100, and if it's like so much faster, and it's like, yeah, A100 is very hard to get in the cloud, they're very expensive, I can't run a lot of things in parallel. Yeah, I would like to see, if I want to run on a lot of images in parallel and kind of run efficiently, cheap, what's the AWS cost versus.
Even for the more expensive things, warping still often dominates.
So
Warping often dominates. Resampling to be on the same grid scale
Yeah.
still often dominates any of the methods. And whether or not they use a GPU to affect convolution kernel rarely does anything. Step. So so
exactly, so I just a little. There's a big difference between running in production and running in something, just isolated cases, and I just wanted to make that point.
I think all of your testing so far has been in the cloud, though, a lot of it, right?
Yeah,
So
but
you've
it's
been
all
sort of looking, yeah,
Yeah, all CPU.
yeah, it's also.
And a pretty small, I've like done some small scale tests. I haven't expanded yet. And like one of the main things I'm really thinking about is Zogi is relatively parameter free, which may be because we're going to be doing different environments, different exposure times. Like there's a lot of things that could change for any given subtraction. And if you've, sort of tuned for one case, where, you know, you have a lot of parameters in your subtraction algorithm, maybe it doesn't work as well for every case. So that's kind of the sort of the main thing I'm thinking about right now, but
If you wanna dive into this. do that. But I'm actually though structurally interested in who and should we start having regular meetings about and subtraction.
sorry,
Well,
what did you say, Dan?
Right, how should we have regular meetings with the people actually like
Yeah.
running this stuff, have thoughts about the code or processing or something?
We have a monthly record meeting.
Well, but there's a new time domain working group, I think that's
Yeah.
okay for.
So that is something that will definitely be discussed there, and the regular meetings that the SMPIT and this group was having, the one that you had on your calendar. So that time will be used by Stride from now on, which will incorporate the things that were being done by SMPIT and Rapid as well. So we should bring those up and make sure that the different groups that are thinking about this know what the other groups are thinking about it. Right.
I think I broadly agree. I found that 30-person meetings are good for people to give presentations and a few questions can be asked. They're different than getting the grad students and postdocs writing code, actually working together
Oh.
such that, which is, I think, where we want to figure out for rapid testing.
Yeah, we can certainly do spin-offs from that. And we were kind of selfishly hoping this conference that there'd be a little bit of tete-a-tete to start to get those discussions.
Yeah, I'm ready to go now, but we have.
So
There's
can
another
I-
meeting.
Can I do a 1 minute pitch for Stride?
Yeah, please.
So the Stride meetings, as I said, is the time domain group for Roman. And it'll meet once a month. But what we do hope is that there'll be some breakout groups, focus groups that will meet 2 weeks of cadence from that. And that's where these things can be specifically done, including coding, etc. And so which groups get formed will depend on the people who start coming to Stride and we can discuss it in that sort of service. And we are also looking for a co-chair there. So if you want to volunteer.
Michael's putting his hands here. Excuse me. Yeah, I think one of the other things is computing power, because I think we still know that the SFFT has been optimized for GPU, but on AWS, the GPU machine is one of the more expensive
I have
machines.
to say, it's also only a part of the pipeline, so it's just, rather than just focusing that, I would just like people to be aware of the whole process and the various constraints. You know, I'm not necessarily impressed by it. It was like, oh, just run this one thing on a A100. It's like, okay, fine, but that's probably not what we're going to do.
The circumstances tends to be different between the cloud and on-prem, because like, if you're in the DOE world, you're like, use NERSC. Like, oh, it has a bunch of GPUs. I guess I better need to use them to do something. I don't care if they're faster. It's just that it's on the note that I'm getting, and that's a different use model that I need to reserve.
I mean, it's just we can get them, but again, we might have to queue for them, which is not what we want.
But I mean, SFT to be specific doesn't require a GPU.
Yeah.
Okay, I don't know how much more you want to comment on these, Jacob. You know, we've just been playing with these. Basically Zogi, SFFP and the sort of cross match between Zogi and SFFP.
Yeah. One question, just to comment, one question that came up in the last quarterly was, in this case, I reprojected both to an undistorted north up reference grid, both the reference and the template. And maybe, you know, especially in a case where you have a really nice mosaic deep template, maybe you don't want to be reprojecting the science image anymore. And so we've started, you know, considering that, but
Yeah, you should reproject to the side image.
sorry,
If the reference is deeper, reproject it to science images.
Yes.
right, into the distorted frame of, you know, whatever SCA took this science image, yeah.
Yeah.
That was it, that was just a small comment,
So just
something
to be
that came
clear,
up, but
all this testing is being done with the Open Universe Sim.
Yeah.
To start with.
Do the open universe sims have different roll angles where you could?
Yes.
Okay, so they're unmatched PSS.
Yeah, in fact, Jacob has been using ones that are total mismatches.
Right.
Yeah.
As you said, adjusting to the same.
Yeah.
So, you know, with part of the optimization is to develop more numerical metrics for evaluating the image differencing. So that's in the process right now. And then all of these sort of trades between efficiency and speed, noise properties, etc. So. Okay, and then we've been doing some work, I guess work is underway this summer on machine learning.
There are two aspects that are happening there. First of all, trying to understand what kind of classifications that we can be doing. So we want to reach a transient classification level, but before that, we need to understand the different kinds of artifacts. So what artifacts can be there from the simulated images? But also, once these injected transients are there, what is it that we need to start classifying them? And one other thing that we're trying is also image subtraction method using machine learning, where there will be no actual subtraction like SOFI, but we'll train pairs of images, one with transient and one without transient, through a decoder encoder, and try to see if we can figure out what the transient is. So we have demonstrated that with some data earlier, but our biggest concern, which is what we want to put to rest, is about hallucinations, because these machine learning algorithms and we're using something like encoder decoder can hallucinate based on the data they are trained with. And that's one thing that we have to make sure that that doesn't happen. So we are not promising that this method will work and it will be available for Roman, but that's something that we are going to try. There's a student working with me right now who's trying that out. So again, having better simulated images with more varied kinds of transients in them will be really useful. So we are using what we have from Proxel for now and hope to expand that.
So I was curious with our simulations of like, there's this like generally do end-to-end for all transients through the pixels to the stuff, but like there's lots of like, wait, it's just a point source, not an extended source. Do I really care exactly what the light curve looks like? But for this case, do you really care exactly what the light curve looks like?
Not the light curve, because this will really
This
depend
is
on
just
the
air.
images.
Okay, yeah. Okay, so just point source on some fuzzy block that's in different separations and point sources on point sources.
Or even point sources where there was nothing there.
You should definitely get that.
Yeah, and also the other way around. So if we
Yeah,
have
right.
a point source that has vanished, we sure.
Sebastian already said those are uninteresting. He doesn't care about those.
The main problem with if this algorithm winds up being most efficient is that we'd have to change our name because it would no longer be image difference. It would no longer be rapid.
That's the biggest issue.
Yeah.
So I don't know if you found something similar, but we built this model, similar model using transformers, and the runtime is comparable to difference imaging.
Oh, no.
Yeah. So yeah, because the model is huge.
Right.
So we're trying to figure that out.
Okay, we should talk more about it, because this the encoder decoder, which will be much smaller.
Okay.
Right.
Okay. Yeah.
It'll be mostly like inferencing the scene.
Yeah. Yeah. The CNN model.
Right.
Okay, so I just mentioned this slide because we're using a homegrown IPAC piece of software, LateGen, to do the image registration. We may also, or instead, wind up using S4. It really all depends on, a lot of it has to do with the distortion and handling the distortion and the keywords in the images. But I think you're using LateGen at this point to do the registration.
Right, for now.
Yeah, for now. Joe's not here, so I can't really comment to any extensive detail on our plans for the solar system objects. But again, it's using a lot of the infrastructure that's already being built for NeoSurveyor in terms of data analysis. Yeah, so again, using a realistic catalog of objects and injecting them into simulations, the existing sims. So I've added this slide. This was something we included in our quarterly set from a couple weeks ago. That it's Ben's hope in particular to get sort of an end-to-end set of simulations that we can use to punish the pipeline. and understand, speed and efficiency and load and volume. It's not, so it doesn't even have to be a perfect set of images, just images that we can use that best represent a campaign or the entire core community survey, for instance. Probably can't do that as if we could start to do it some with the open universe sims, but they're only a subset of what we would probably encounter in reality. Michael, you look puzzled.
All right, I was trying to be quiet.
Okay. All right, so community engagement, we've mentioned we have an external advisory board. Ori's on that board, he's online here, or he was online. Eric Bellum's our chair, several other people, Keisha Day, Dee Smoller, Carmen Rest, and Dave Trilling. These are people also that if you have input you want to funnel our way, you certainly are free to contact these people and give them thoughts. We're meeting quarterly with them. They gave us a number of recommendations for this coming quarter and for the future, which is great. And that sort of interaction as well as what we're doing today is exactly what we're looking for. So here's the stride slide. So again, I think you can go to the working groups page, the Roman working groups page, to sign up for the time domain working group. Okay, so I put out this plea several months ago, I think, it wasn't that long ago, for all kinds of other transients, all the things that you know and love and would want to discover with Roman. We're looking for light curves, even better than that. Multi-epoch SEDs, or spectra from UV to the near IR. We're not asking for a lot. But for those of you who have data sets that are happy and willing to contribute it to us, let us know. This was just a quick brain dump laundry list that we put together. But other things that you can think of that we haven't included, or that the open universe sims haven't included. Okay, community engagement. Please sign up for our announcements. You probably already got Rapid Announce, which is why you're here. But if you're not, and please sign up for our announcements, because that's the best way to get our push information for sessions like this and other things that we're doing. Always feel free to send us email with input. We're open 24 hours. Right.
The email address is open 24 hours.
Yeah, exactly.
Yeah. It's only done with space.
Maybe even longer. Our website is still in development, but we're hoping to use it as again a good push-pull interface with the community. I changed this up. That QR code is now good for an invite to the Rapid Slack. So that's another vehicle that we can that is available for you to interact with us. So we want your input and your feedback. And as I showed yesterday in my little bit, Rapid is currently hiring. We have an open ad right now for application developer, early career, Python, SQL experience. Any other experiences are good. There's an ad to respond to. We will be running an ad soon, looking for another junior early career staff scientist for either later this calendar year or beginning of next at the latest. So please forward to us any potential candidates. Please encourage people to apply if you know people who would fit in well with our project, and influence us to go certain directions. And there'll be further employment opportunities in FY 25 because it's a small team and we need to do this on the scale we want. We need more people. All right, so the floor is still open. We've had great discussion. I really appreciate all of you coming and providing this input. And hopefully this is just the beginning. If you have more ideas and thoughts questions and suggestions, it's all good. We just want crossflow with the community because you're going to get the alerts and all the other products that we're providing. So we need your input on what they should look like. So yeah, the floor is still open. Is there any lingering questions or thoughts or comments? Anybody online? A question or comment? Okay. Good. All right.
Yes,
I have a question. Skylar, I guess we will address the question of follow-up of with other telescopes down not in space but the ground-based telescopes. We can follow up which possibilities we can afford each of the members of this collaboration for this, or this in another session perhaps, or
so
you don't plan to have,
yeah, so you're talking about are there going to be dedicated programs on ground-based telescopes to support this sort of time domain discovery?
Yeah.
I don't know of anything yet that's established. Whether there are collaborations in the room, people who are looking.
Does tomorrow have any?
I was not busy. What's the question?
So Pilar is asking about, programs that have at ground-based facilities for Roman time domain follow-up.
So yeah, Solar is basically guaranteeing 100 nights for Roman related stuff. And that's how we use that. We don't know yet. But I mean, we can independently propose whatever follow-up proposal as well. I guess these 100 nights may be oversubscribed by other. It's like including whatever everything. It's 100 nights. So we can't. It's not all for transients. I mean, we can always propose independent.
I didn't hear very well which telescope did you say? Where you have the 100 nights?
Subaru telescope.
Subaru,
Subaru, okay, perfect.
That I think is probably one of the only established programs at this point. I mean,
yeah, I guess so. Yeah.
Yeah. I mean, presumably people will submit for Tech Gemini.
Yeah.
Yes, I could submit for the Grand Tecan in the Canary Islands because I already have programs like those running there, and I can also submit to the Extreme Large Telescope ELT with other people.
So that's a good topic for the time domain working group. That would be a good session.
Yeah, for follow-up. Yeah, so those of you online certainly can join the Roman time domain working group. Okay, any other questions in the room?
Well, I just had a comment. We will, of course, be setting up a Kafka endpoint to serve alerts. So if any other part of Roman would like their own topic, that's trivial to do. We found that at CTF, like once you have an endpoint, we want to feed all sorts of things to the downstream brokers. So yeah, we're totally into that.
So potentially a little far out. We're interested in astrometric microlensing, and I don't know how good like the difference imaging is for like changes in position.
Oh my.
Yeah. I think you asked that question yesterday.
Yeah.
Yeah.
Yeah, nobody's ever done the astrometric transient sky before. Gaia nearly did it with Gaia Photometrical Earth. They never got around to it. It's completely uncharted territory.
Yeah.
That sounds hard.
Yeah.
There's fun math about why that's hard.
That sounds hard.
For another time, yeah. Yeah, I don't know, we could see. Yeah.
Yeah.
Okay, anything else? All right, so I will put in a plug for the Supernova Pit meeting in 10 minutes. For those of you in this room, a lot of us have to be up there. Upstairs, what did I say? Downstairs?
We're just.
Oh, sorry.
I think it's in that. area.
Yeah, it is. It's upstairs, 4th floor. Don't listen to this. Don't listen to the man behind the curtain. 4th floor. Yeah, it's probably easier to find than this room.
I don't know, we're already here.
We'll have a boisterous crowd.
Thanks very much, guys.
Yeah, thank you all for coming. Appreciate it. Thanks everyone online.
It's submitted.